Hi everyone, this is the last video for position, velocity, and acceleration. So we're going to talk about two really important things here. We're going to talk about when a particle is moving towards or away from the origin, and then we're going to talk about how to figure out when a particle is furthest from the origin. So let's go ahead and start, obviously, with the first one, moving towards or away from the origin. So in order to do this, we have to look at both the position and the velocity. So I'm going to go ahead and kind of divide this in half right now, and we're going to first look at when a particle is moving towards the origin. So there are kind of two cases that we have to consider. So if we think about a number line, and we're going to put 0 in the middle because that's the origin, let's say that we started over here on the right. So let's go ahead and say that our position, S of t, is greater than 0 because it's to the right. Now if I want to be moving towards the origin, then that would mean I have to move to the left. So if my position is greater than 0 and my velocity is less than 0, then I'm moving towards the origin because I started at the right and I'm moving towards the left. The other option could be that we start on the left. So it could be that S of t is less than 0, but we're moving to the right. So and the velocity is greater than 0. So I know it's kind of squished in there, but hopefully that makes sense. If I start over on the left, it means my position is negative. But if I'm moving to the right, I'm moving towards the origin. So now let's talk about moving away from the origin. So again, let's look at a number line. And if I put 0 in the middle, I could start over on the right, which would mean that my position is greater than 0. And I want to move away from the origin, so my velocity is greater than 0 also, because I'm moving to the right. The other option there could be that we start on the left, so my position, S of t, is less than 0, and I'm moving to the left, so my velocity is less than 0. Alright, I know that sounds all a little weird, but hopefully that kind of makes sense, and when we do a real example, I think it kind of clicks, so just bear with me for a little bit. Talking about how to figure out when a particle is furthest from the origin, we need to look at the maximum and the minimum position. So hopefully when I say that we're looking for a min or max of the position, you know exactly what I'm talking about. You know that we need to look at the first derivative. So we need to take the derivative of the position, which really means we're finding the velocity function, set this equal to 0, and make an options chart. Make sure you note that we need to include the endpoints because we're going to be given a closed interval, so we want to make sure we include the endpoints in our options chart. Then we're going to find the largest and the smallest values to see which one is, we're not going to say largest, we're actually going to say the farthest from 0. So it could be that our maximum is the farthest away, or it could be that our minimum is the farthest away. Just because our minimum is negative doesn't mean that it's not the farthest distance. Okay? So a particle moves along a line so that its position is given by t squared minus 3t plus 1. S is measured in meters and t is measured in seconds. So at time t equals 4 is the particle moving towards or away from the origin. So we set up here that in order to determine this, we need to look at the position and the velocity. So let's start with position. So S of 4 means just plug 4 in here. So 4 squared is 16, 3 times 4 is 12, so 16 minus 12 plus 1 is 5. And we know that 5 is greater than 0. So it means we started to the right of the origin. So if we were to draw ourselves a little sketch here to kind of start thinking about it, here's the origin and we started on 5. All right, we started to the right of the origin. Then we need to look at the velocity. Well, I'm going to go up here really quick and just find the velocity function up here. So if I take the derivative, it's 2t minus 3. So if I want the velocity at 4, that's going to be 2 times 4, which is 8, minus 3, which gives me 5, and 5 is greater than 0. Well, if my velocity is greater than 0, I know that I'm moving to the right, which means I started at 5 and I'm moving to the right. That means based on this analysis, at time t equals 4, the particle is moving away from the origin. We started on the right and we're moving towards the right, so clearly we're getting farther and farther away from 0. For question 2, we're looking at the same thing here, it's just that now we're looking at time t equals 1. So we're still going to do the same thing though. We're going to find the position at 1. So s of 1 is going to equal 1 squared is 1, minus 3 times 1, so that's minus 3, plus 1. So we have negative 2 plus 1, which gives us negative 1. So that means the position at 1 is negative, which is less than 0. So we're starting to the left of the origin. Then we need to consider the velocity at 1. So the velocity at 1 is going to be 2 times 1 is 2, minus 3, which is negative 1. That's also less than 0, obviously. So if my velocity is negative, I'm going to move to the left. So again, kind of in our heads, or even over on the side, we can think about if this is 0, and I'm starting at negative 1, and I'm moving to the left, I'm moving away from the origin. So at t equals 1, the particle is moving away from the origin. Because I started on the left and I'm moving to the left. Question 3 asks for time t equals 1 again, so we're actually going to go ahead and cross that off and we're going to skip that. We're going to move on down then to question 4. So over the interval from 0 to 2, when is the particle furthest from the origin? So furthest from the origin, we said we need to look at the min and the max positions. So we need to take the derivative and find our critical values and make our options chart. So we already know that the velocity is 2t minus 3. So if we set that equal to 0, 2t minus 3, so we get t is equal to 3/2 or 1.5. All right, so then we need to make our options chart. Now we're making an options chart for the position. So it's going to be t and the position, which is s of t. We're going on the closed interval from 0 to 2, and our critical value that we have here is 3/2 or 3 over 2. So if we look at the position function, if we plug in 0, that's nice and easy. We'd have 0. To do 3/2, so we need 3/2 squared minus 3 times 3/2 plus 1. So 9/4 minus 9/2 plus 1. If we get a common denominator, 9/4 minus 18/4 plus 4/4. So 9 minus 18 is negative 9, plus 4 is negative 5. So we'd have negative 5 over 4, which we know is negative 1.25. And then if we plug 2 into our position function, we'd have 4 minus 6, which is 2. 4 minus 6 is negative 2. And then plus 1, that would give us a negative 1. So when we look here, we're looking for the largest and the smallest to see which one is the farthest from 0. Well, when we look here, the largest is 0, so that's not away from 0 at all. The smallest is negative 1.25. So we're looking at the distance there, which is a positive 1.25. So what we would say here is that at time t equals 3 halves seconds, or 1.5 seconds, the particle is the farthest from the origin. Because that is the farthest away from 0 that we get. All right. Now that we have this, we can finish up the practice that we have on position, velocity, and acceleration. And then once we do that, we will be able to move on to the next section. All right. Bye.